This is our planet, the Earth. It's a remarkable, ever-changing world, full of natural wonders. But there's more to Earth than this. Because our planet is unique in the solar system, perhaps even in the universe. My name's Ian Stewart, and I want to show you how our planet works. In this series, I'm exploring the 4 powerful forces that have worked together to create our world.
Wow.
Volcanoes, the atmosphere, ice. But this week, I want to show you the power of the oceans. I'm in the middle of the Atlantic Ocean. It's only when you get out here that you fully appreciate the sheer vastness of the sea. But the oceans are far more than just huge reservoirs of water. They have transformed our planet. Their brute force carves the coastline. And they can leave an extraordinary legacy. They transfer energy around the planet and drive the climate. But above all, we're now beginning to understand how the oceans are connected by an incredible network of currents. They're so critical to the health of our world that when they failed, it helped cause the greatest extinction in Earth's history. The immense power of the ocean allows it to shape the appearance and behaviour of the entire planet and everything living on it. Three-quarters of the Earth is covered in water. It's why we call it the blue planet. But imagine our world without its oceans. And instead, all that water gathered together in a ball. This is what it would look like. Not that much, really. But this is what separates Earth from every other planet in the solar system. Spread out across the Earth's surface, it transforms our world. The oceans have been here for almost 4 billion years, carving the coastline, driving the climate, and controlling the destiny of life itself. This is Hawaii. It's one of the best places in the world to see the raw power of the oceans. But these waves are so much more than just foaming white water. They are the key to understanding the first great role of the sea. Because what you're seeing is the ocean's extraordinary ability to carry energy around the planet. In this case, it's energy captured from the atmosphere that's turned into the brute force of a crashing wave. Even the mightiest waves begin far out at sea, often triggered by nothing more than a gentle breeze. First, a few ripples form, These act like sails, capturing the power of the wind. Steadily, the ripples grow until they become deep swells. But don't be fooled. This isn't water travelling. It's just energy.
When you look at a surfer sitting on his board, waiting to catch a wave, something strange happens. Although the wave moves forward, the surfer doesn't go with it. The wave just passes through, lifting the water and the surfer up and down in the process. In effect, the ocean's just transferring the energy of the wave to the water in front of it.
And this movement of energy is so efficient, it would carry on pretty much forever, if the land didn't get in the way. When the wave arrives at the shore, the water becomes shallow, so the base of the wave slows down. But the top runs on ahead until the inevitable happens. The peak topples over, creating the breaking wave. This is the moment when the energy captured from the wind in the distant mid-ocean is finally unleashed. The largest waves crash down with the force of a 4-ton weight landing on your chest. Without water around you to absorb the blow, it would be fatal. But there is another, far greater source of energy that the oceans capture. The energy that creates the tides comes from our nearest neighbour in space. The moon's gravity tugs at the water in our oceans while the Earth rotates beneath it. But the moon doesn't always act alone. On just a few days of the year, the moon and the sun line up together, and their combined gravitational pull unleashes an extraordinary phenomenon.
I'm in Arari, a small town in the Amazon basin, and to be honest, I'm wondering why. I've flown halfway around the world to be covered in mud and probably rained upon. And all for an ocean phenomenon that I'm not entirely sure is going to happen. But if it does, I'm going to get to see tides behave in a quite spectacular way.
On just a couple of days each year, unusually large tides in the Atlantic Ocean get funneled into the mouths of the local rivers. As the tide rolls inland and gets forced into the increasingly shallow water of the river, it turns into a single, powerful, surging wave. A tidal bore.
This tide is a bit unpredictable, and I'm not exactly sure what's going to happen, but what we expect to happen is for a wall of water to pour up from over that direction. Now what should happen is we should hear it first, because you hear a little rumbling. Is that it coming? I think that's it. You can just see along the horizon there a little low froth. Oh my. It's the whole width of the river. We better go now. Yeah? Okay. It's over there, I know, I can see it. Surprising thing, the most worrying thing is the speed of that wave. It's a pretty fast boat and we're just staying ahead of it. This is mayhem.
The energy of the tide is phenomenal. It can roll inland for tens of kilometres.
We normally think of rivers flowing out to the sea, but the power, the tidal surge here, means that it goes upstream. I mean, this channel is about 400 metres wide, but the force of the tide makes the river run backward.